Do you guys remember this equation? The cosine of theta squared plus the sine of theta squared equals 1. This is one of the first equations you learn in trigonometry, aka pre-calculus. And today, we're going to explore this so we never have to memorize this formula, but we inherently will understand it. The more you ask why, the more you ingrain it in your head by proving it, instead of just trying to memorize, which you're going to forget inevitably. So we're going to prove this today. To understand this equation, to understand this theorem, we have to pull from both geometry and algebra 2. So it all builds on things in the past. What does it build on from geometry? It builds on what is sine, what is cosine. Now, what do we pull from in algebra 2? Does this ring a bell at all? This is conics. What are conics? Conics are what happens when you take a plane and you cut a cone in different ways. I will do a much longer video in the future on conics. But in algebra 2, we learned about different conic shapes. Parabola, which you learn in algebra, circle, ellipse, and hyperbola. Those are your 4 conic shapes. So if you remember this formula, this is the formula for a circle. The P and the Q are where the circle is shifted. So where is its center when you plot it on a graph, a Cartesian plane? And then on this side of the equation is the radius squared. I will review that part of algebra 2 in the future. But right now, if you want to brush up on your foundations when it comes to conics, I recommend you look it up. So now we have the foundations. Let's start deriving this formula. The first thing to know is if the circle is in the center, so if its origin is at 0, 0, then we don't have a p value and we don't have a q value. So the equation for the circle then is just x squared plus y squared equals the radius squared. If we set the radius equal to 1, then we get x squared plus y squared equals 1. So now let's draw the circle when it's x squared plus y squared equals 1. Well, since we know the radius squared is 1, so 1 squared is 1, the radius is 1. So if you draw it on a graph in xy plane, the farthest extent, of course, is the radius, right? So it intersects the x-axis at 1, 0, negative 1, 0. It intersects the y-axis at 0, 1, and 0, negative 1. So this is what the circle looks like. In fact, for those of you who remember your math, this is called the unit circle. So once we have drawn a unit circle, we now have to remember SOHCAHTOA. Remember SOHCAHTOA? That's your shortcut for reminding yourself what the sine, the cosine, and the tan are. Sine is the opposite side over the hypotenuse. Cosine of the angle is the adjacent side over the hypotenuse. And tangent, which we are not dealing with in this, is the opposite side over the adjacent side. So now we have defined all our terms. Let's derive this formula. Here I've drawn a right triangle with the angle theta. And if you look at the right triangle put into this unit circle, what we can find is that the hypotenuse is the radius. And what have we determined? The radius is 1 in our unit circle. So the hypotenuse is 1. And while we're at it, let's just review. What is the sine? The sine would be the opposite over the hypotenuse. The cosine would be the adjacent over the hypotenuse. So here I've written it for you guys. The sine of the theta is the y value over the hypotenuse, and the cosine is the x value over the hypotenuse. But we also just determined that in a unit circle, the hypotenuse is the length of the radius, which is 1. So that means the sine of theta is y over the hypotenuse, which is 1, so y over 1, which is y. And the cosine of the theta is x over hypotenuse, aka x over 1, which is x. So now we can write it as x equals cosine of theta and y equals sine of theta. Remember this, guys, now? Remember this equation of the unit circle when it's in the center, the origin, and it's not shifted anywhere, and the radius is 1. This is the equation. X squared plus y squared equals 1. We also just determined that x equals cosine of theta and y equals sine of theta. So what can we do? We can substitute or plug in for x and y. What does that get us, guys? Once you plug it in, gets us this. So cosine of theta squared, also known as cosine squared of theta, plus sine of theta squared, also known as sine squared of theta, equals 1. So what did we just do, guys? We derived a fundamental trigonometry formula, and we used our existing understanding of geometry, algebra, and algebra 2. We built it from the things we already know and the things we have already proven. The more you understand from the first principles, the more these things will be fun. And even if they're not fun, they will be easier than trying to memorize a million things. So I hope this inspires you. I hope this shows you the beauty of math. I know our education system a lot of times did not teach math correctly, but it's never too late to learn it correctly. And even more importantly, once you learn it correctly, how can you use this and apply it? Because I guarantee you, when you have these skills and you can apply it to whatever field you're in, you're going to have a leg up on the competition. And from an understanding perspective, you're going to understand whatever you're trying to do way better. So more to come. Trigonometry is often where everything falls apart. That's honestly where it fell apart for me. And it took me 2 more math classes before I started having trouble, which is in multivariable calculus. But inevitably, the lack of trig fundamentals, which also came from certain holes in my algebra 2 fundamentals, which also came from holes in geometry and algebra, eventually compounded in me having trouble in the last few units of multivariable calculus. So there's a method to a madness to all this, and I'm trying to correct the wrongs of my math education, and I hope it inspires you to not go down the path that I did and have holes that will eventually bite you in your behind. Talk to you guys soon.